1. Task Introduction. This task involves studying the circuit control of the CNC machine tool spindle control system in an intelligent manufacturing production line. Learners will understand the circuit composition of a variable frequency drive, VFD, gain clarity on the design, wiring, and commissioning of the VFD circuit, and learn the parameter tuning process for the VFD, including the required parameter settings and their meanings. The goal is to enable learners to correctly configure the spindle control system parameters to ensure its proper and stable operation. 2. Learning objectives. Knowledge objectives. Learn how to design the spindle VFD circuit. Understand the adjustment process of the VFD and the meaning of related parameters. Master the decoding commands for PLC control of the spindle VFD and their applications. Skill objectives. Correctly wire and commission the VFD circuit. Accurately configure the VFD adjustment parameters. Properly program the PLC control logic for the spindle VFD to achieve forward and reverse spindle rotation. Caliber objectives. Appreciate the essence of craftsmanship and strive for excellence in work. Cultivate a spirit of exploration and the courage to face challenges. Develop professional qualities such as optimism, dedication, and focus. 3. Guiding questions. 1. What is the control principle of a VFD? A VFD converts the standard 50 Hz power supply into a power source with the desired frequency to control the motor's rotational speed. First, the incoming AC power is rectified and filtered, converting it into DC power. The control circuit modulates the analog voltage signal from the CNC system using a triangular wave, generating a control signal with a specific frequency. This control signal and the DC power are fed into the inverter circuit, which inverts the DC power into AC power at the same frequency as the control signal. The AC output is then supplied to the motor, enabling precise speed control. 2. What are the main components of the VFD circuit when the CNC system controls the spindle? The VFD circuit consists of the following parts: high-power input circuit. The input voltage and phase configuration vary depending on the specific VFD model and the motor's power rating. High-power output circuit outputs controlled power from the VFD to the motor. System command circuit receives control signals from the CNC system, typically using a 0 to 10 volts analog signal for speed regulation. Forward and reverse rotation control circuit, usually managed by a PLC to control the spindle's direction of rotation. 4. Knowledge description. 1. Spindle control circuit diagram. The CNC machine tool spindle adopts analog spindle control, which means it is controlled by a VFD. The circuit diagram is shown here. 1. High-power input. Terminals L1, L2, and L3 are the high-power input terminals. When the motor power is relatively small, a single-phase power supply of 200 to 240 volts can be used, connected to terminals L1 and L2. When the motor power is relatively large, a three-phase power supply of 380 volts is used, connected to terminals L1, L2, and L3. 2. High-power output. Terminals U, V, and W are the high-power output control terminals connected to the motor. 3. Command control. This VFD uses a 0 to 10 volts voltage control method, with input via the AI and GND terminals. The signal comes from the CNC system. The magnitude of the input voltage is proportional to the spindle rotation speed. 4. Motor forward and reverse rotation control. Forward and reverse rotation control is achieved through the multifunction terminals of the VFD, which are controlled by the CNC machine tool. Terminals X1 to X4 are multifunction terminals of the VFD. X1 and X2 are configured as multifunction terminals for forward and reverse control. The PLC controls relays to connect X1 and X2 to the COM terminal, thereby enabling forward and reverse rotation. The specific control circuit is shown here. 2. VFD commissioning. 1. VFD commissioning. 1. Control panel description. As shown in the diagram, the 7-segment display primarily serves a monitoring function. It displays the monitoring status, showing parameter values, the operation status, indicating function groups, function codes and parameters, and the fault status, presenting fault codes. The func key is the function key, mainly used to switch between function code groups, navigate menus, and return to the previous menu level. The set key is the setting key, used to enter the next menu level and confirm parameter settings. Up arrow and down arrow keys are used to increase or decrease parameter groups, function codes, or parameter values. The rotary knob is used to adjust the operating frequency during manual operation. 2. 7-segment display description. The display shows 5 digits, capable of representing 6 significant digits. To view the first 5 significant digits, press func plus up arrow. To view the last 5 significant digits, press func plus down arrow. 2. Common commissioning parameters and their descriptions. 1. Group B, basic system parameters. To commission the VFD, the basic system, power, and control parameters must be configured in sequence. Begin by setting the Group B basic system parameters. These parameters mainly include access permission settings, parameter initialization, and password settings. During commissioning, set access permission to 2 advanced parameters. Then perform parameter initialization by setting B0.10 to 1 to restore factory settings. 2. Group C, power parameters. As shown in the table, the Group C parameters are power parameters. These mainly configure the motor's rated power, rated voltage, rated current, rated frequency, and rated speed. The CNC machine tool used in the automated production line is equipped with a 0.75 kilowatts motor with single-phase voltage input, thus operating at 220 volts. The motor's rated current is 0.48 amperes, running on standard AC power with a rated frequency of 50 Hz. It has 2 pairs of magnetic poles, giving a rated speed of 1,440 revolutions per minute. Because the motor power is small and the impact load is low, the VF curve mode uses a linear curve. See the table for specific parameter settings. 3. Group E, function control parameters. As shown in the table, Group E contains the main function control parameters. E0.00 defines the primary frequency setting source, determining how the motor's frequency value is set for variable frequency speed control. The available options include settings via the control panel knob, control panel buttons, AI1 analog input, digital terminal input, communication input, and multi-step speed settings. Since the CNC system controls the VFD of the CNC machine tool, option 2, AI1 analog input is selected. E0.01 defines the source of the primary run command. Options include the control panel input, multifunction digital input, and communication input. When the CNC machine tool uses a VFD to control the spindle, the forward and reverse rotation of the spindle motor is managed via PLC control, which switches multifunction terminals and the COM terminal to achieve direction control. Therefore, select option 1, multifunction digital input. E0.17 sets the motor rotation control mode. Since the spindle needs to support both forward and reverse rotation, option 0, forward reverse rotation control mode is selected. E1.00 and E1.01 define X1 and X2 input settings. The multifunction terminals support 51 selectable functions. For the CNC machine tool, these terminals are primarily used to control the spindle motor's forward and reverse rotation. Thus, X1 is set to 35, forward rotation control, and X2 is set to 36, reverse rotation control. E1.35 sets the AI1 input mode, specifying the input signal format for the CNC system's output command. The VFD can accept input signals in the form of 0 to 20 milliamperes, 4 to 20 milliamperes, 0 to 10 volts, 0 to 5 volts, and 2 to 10 volts. The CNC machine tool uses a 0 to 10 volts control signal. 3. Spindle control PLC programming. 1. Fundamental knowledge analysis. 1. M-code decoding. M-codes are used to control auxiliary machine tool operations. When a CNC machine tool executes an M-code in a machining program, the CNC system outputs the M-code signal in either BCD or binary format to specific PMC code registers F10 to F13. The PMC must decode these M-code signals to convert them into single-bit logic states with specific function meanings. This allows the system to recognize the code type and perform the corresponding auxiliary function control. 2. Spindle forward and reverse rotation. Spindle forward rotation refers to the spindle rotating in the positive direction. Spindle reverse rotation refers to the spindle rotating in the opposite direction. The spindle's rotation direction can be controlled manually or automatically. Manual control. In manual continuous feed mode or handwheel feed mode, pressing the spindle forward or reverse button causes the spindle to rotate in the respective direction. Pressing the spindle stop button stops the spindle. Automatic control. When the CNC system is in automatic, remote, or MDI manual data input mode, executing M03 causes the spindle to rotate forward. Executing M04 causes the spindle to rotate in reverse. Executing M05 stops the spindle. 2. Decoding command analysis. DEC, binary decoding. Function. The DEC command is used to decode binary coded data. When any one of the specified 8-bit, 1 byte, or 16-bit, 2 bytes, continuous data matches the given code data, the corresponding output data bit is set to 1. If no match is found, the output is 0. This command is typically used for decoding M-codes or T-codes. The format is as shown in the diagram. Control conditions. ACT equals 0, resets all output bits. ACT equals 1, performs data decoding, and the result is stored at the output address. Parameters. Length defines the size of the code data in the first parameter bit. 0001. The code data is a 1-byte binary value. 0002. The code data is a 2-byte binary value. S1. Code data address. It specifies the address where the code data to be decoded is stored. S2. Decoding target. It specifies the first of 8 1-byte or 16 2-byte consecutive data values to be decoded. S3. Decoding result address. It specifies the address where the decoding result is output. The storage area must provide 1 or 2 bytes of space for the result. 3. Programming. 1. Decoding. When the M-code selection signal F7.0 is valid, decoding begins with M03 with the result output to R3. The decoded signals for M04 and M05 are then extracted and output to R4.0 and R5.0, respectively. 2. Spindle rotation conditions. Spindle rotation conditions refer to the prerequisites for the spindle to operate normally. The specific conditions are as follows. The spindle stops when any of the following actions occur. Emergency stop G8.4 equals 1. Reset F1.1 equals 1. Fault alarm R119.0 equals 1 and F1.0 equals 1. Tool change R55.1 equals 1. Spindle and stop state R102.0 equals 1. Spindle positioning and accurate stop R52.0 equals 1. And M05 command execution R5.0 equals 1. When the spindle stops under these conditions, R4.5 equals 1. 3. Manual and automatic control of spindle operation. Automatic or MDI mode control. In automatic or MDI mode, R280.1 equals 1 is output. Manual key control of spindle forward and reverse rotation. Pressing the manual forward rotation key, X25.2, or reverse rotation key, X23.2. Provided that rapid feed is inactive, F2.6 equals 1. Cutting feed is inactive, F2.1 equals 1. And no alarm condition is present, F1.0 equals 1. Will output the forward rotation signal, R23.3, or reverse rotation signal, R23.7. Manual key control of spindle jog. When the forward rotation key, X25.2, or reverse rotation key, X23.2, is pressed along with the spindle jog key, F43.0, while the spindle stop key, X24.2, is not pressed, an emergency stop, reset, and alarm signals are inactive, and the operation time has not exceeded the preset time, R199.0. The control signals are 198.3 and R198.7 for spindle forward and reverse jog are output. Spindle forward and reverse operation control. The control of spindle forward and reverse rotation includes the following three modes. Mode 1. Automatic spindle control. In automatic mode or MDI mode, R280.1. Executing the M03, R3.0, or M04, R4.0 command, while meeting startup conditions, R4.5 equals 0. Results in the output of forward rotation signal, R400.3, and reverse rotation signal, R400.4. These signals control Y0.4 and Y0.3, which are sent to the VFD, enabling spindle forward and reverse operation. Mode 2. Manual continuous operation spindle control. In manual mode, pressing the manual forward or reverse button outputs R23.3 and R23.7, thereby controlling the spindle's forward and reverse rotation. Mode 3. Manual spindle jog control. In manual mode, pressing the manual forward or reverse button along with the jog button outputs R198.3 or R198.7, initiating jog forward or reverse operation. Once the operation time expires, R198.3 or R198.7 is deactivated. 4. M command completion control. When M03, M04, or M05 command is executed, i.e., R3.0 equals 1, R4.0 equals 1, or R5.0 equals 1, and the forward and reverse rotation signals have not stopped for longer than the preset time, R102.0 equals 1. The system outputs are 271.0, which in turn controls R7.4, ultimately outputting G4.3 to signal that the M command execution has completed. 5. Task implementation. 1. According to the circuit diagram, correctly connect the VFD circuit and perform an inspection to ensure that the input voltage is correct and that the system command and forward and reverse control circuit terminals are properly connected. 2. After powering on, set the VFD parameters, including the basic parameters in Group B, Group C, and Group E. 3. After completing the parameter settings, input the correct PLC program into the system. In MDI mode, input M03S500 to verify whether the VFD controls the motor to operate, whether the running speed is normal, and whether the motor's forward and reverse rotation is functioning properly. If all the above are normal, the commissioning is complete. If not, adjust the relevant parameters until the system operates normally. 4. After completing parameter commissioning, input the compiled PLC program for spindle forward and reverse rotation control into the CNC system. Then, in automatic or MDI mode, execute M03S300 and M04S300 to verify whether the spindle forward and reverse rotation functions properly under automatic mode, and observe whether the M03 and M04 command execution complete normally. If not, commission the program until the spindle operates correctly in automatic mode. Finally, in manual mode, press the spindle forward and reverse buttons to verify whether the program functions correctly under manual operation. This lecture ends here. Thank you.